Welcome, everybody. Sorry for the delay tonight, but we appreciate your attendance here. Happy New Year. And, so thanks for your patience in all the scheduling we had to do this month. It's been a bit of a challenge, but, we'll make it all work out. So I always get started by thanking our, let's see. So our agenda is we thank our sponsors, talk a little bit about what's new. I'm going to introduce Reza Rahman, and then afterwards we do our usual upcoming events. But what's new tonight, we're going to look at the fuj.io website, just a couple of things for 5 minutes. There's a lot of what's new on there, and these are great resources for the Java community, especially introductory type videos, for those wanting to learn Java, all kinds of information about the Java user groups and things like this. So more about that later. And then, of course, we'll have our usual giveaway to IntelliJ IDEA. And I think what we'll do is we'll include, Reza brought some nice gifts to give away. This is a phone charger. We have some shirts, some books. So maybe we'll use the QR code and then just, randomly give them away that way. So. All right, so our sponsors, that would help. JFrog is our platinum sponsor. We appreciate their support over the last third year now that they're going to sponsor us. And then look for some giveaways from them. Ari Waller is my main contact for JFrog, and he'll come in and he'll usually, speak 5 minutes about upcoming events related to JFrog. There is a new book on DevOps by 4 of the employees. And then you have what they call a Swamp Up conference in New York, and they give away, I think, either free or discounted tickets for that. So you'll hear more about this throughout the year. Our silver sponsor is Azure. As you know, they have a downstream distribution of OpenJDK. And then we are partnered with DevNexus. This conference will be coming up April 4th through 6th, I believe, is the correct dates. This event is the who's who of the Java luminaries. So, Reza, are you speaking at that?
Yes.
That's what I thought, yes. So Reza will be there. Billy Corando, who, spoke with us about a year ago. Merrick Rogleski, some of these folks who presented here will be presenting live in Atlanta. And we have our per meeting sponsors, JetBrains, of course, they're the makers of IntelliJ IDEA. And then also Eclipse Foundation and Jakarta EE. They supply the Crowdcast hosting that we initially used when we got started, but that is there for us in case we need it. All right, so what's new? I may have mentioned this last month. We are contributing members to the microprofile working group. And because of that, we can be a guest member of the Jakarta EE working group. And this made sense. There was no additional funds to be a guest member. I myself, I'm a committer on 2 of the specifications, Jakarta NoSQL, which Reza is going to talk about tonight. And there's a new one, Jakarta Data. We also have adopted both of those specifications. The Jakarta EE folks, they encourage Java groups to become more involved, and we've done that for sure. Microprofile 6, after a slight delay, was released technically at the end of last year, but they didn't announce it until right after the new year. So there's and some of the specifications have been upgraded. And there's also a new spec, telemetry version 1.0. which replaces the open tracing specification. That was one of the originals from maybe version 1.3. What else? And I mentioned those 2 specs. They are on track to be part of Jakarta EE 11. There's some work to do still, and a lot of that has changed over the last couple of months. I believe, if I'm not mistaken, they're targeting first quarter of next year for the release of Jakarta EE 11. All right, so, and then there's a guide to contributing to Jakarta EE 11. This was actually created by Reza, and I believe the link is out there for the public. So I don't know if you plan on mentioning that maybe.
I'll show you.
Okay, so then, yeah, so that's something, that some of the folks had input and, and then it was released to the Java community. All right, so that's enough of me talking. And don't forget there's lots of pizza there, so please help yourself. And so Reza Rahman is a principal program manager for Java at Azure at Microsoft. He works to make sure Java developers are first-class citizens at Microsoft, and Microsoft is a first-class citizen of the ecosystem. That doesn't sound right. I must have flubbed that on the right there. Sorry. All right. So Reza has been an official Java technologist originally at Oracle. Is the author of the popular book EJB in Action from Manning. Reza has been been a frequent speaker at Java user groups and conferences worldwide, including JavaOne and Devoxx. He has been the lead for Java EE track at JavaOne, as well as a JavaOne Rock Star. And that is a cool title, by the way, to get that title. It's, that's not an easy thing. He was the program chair for the inaugural Jakarta One conference. And I can talk about that for a second. That was debuted in 2019. And this was a virtual conference before virtual conferences were actually mandatory or necessary. So this was pre-COVID. It was a 19-hour event, I remember. This way, people around the world could participate remotely. It has evolved now over the past 3 years to like roughly a 12-hour event, but still, it's all virtual. It's a really great conference. I was pleased to be part of a program on the program committee for 2 years. So it's a really good event. So look for that later this year in probably September, December timeframe. Reza is an avid contributor to industry journals like DZone. I have to twist his arm to write for InfoQ maybe. So he has been a member of Java EE, EJB, JMS expert groups over the years. Reza has implemented the EJB container for the Resin open source Java EE application. He helps lead the Philadelphia Java users groups, one of our friends of GSJUJ. And Reza is proud to be a founding member of the Jakarta EE Ambassadors, which was originally the Java EE Guardians, that's it, yes. And this had to do with the release of Java EE 8 and all that. And then because this group and MicroProfile emerged because of that. Personally, Reza, a good friend of mine. We've talked about personal things, about me getting involved in open source. So I appreciate your counsel on all that stuff. So without further ado, Reza, the floor is yours.
Hopefully everything is set up okay enough.
Not
see.
yet.
All right.
Yeah. No. And give it a try.
All right. Oh boy, I hear echo of myself. Is that normal?
Mute yourself.
All right.
Not mute yourself. Turn the speaker off.
Okay. Yeah, the speaker's off.
Okay.
Barry,
Yeah.
Chandra's asking if the live stream has started. Oh,
Okay. Because I see. All right.
I'm not leaving here.
The live stream is going. If the live stream hasn't started.
Mike, are you on the live stream? Just checking.
It says end stream. We should be good.
All right. Do you need to swap the display over to me? Do I need to do something here? Okay. Oh, I need to share my screen. Okay.
Zoom wise.
All right. And yes.
No, you know what?
Okay. Is that all? That's all I needed to do?
I don't think I talk.
Hello, 1, 2, 3. Hello, 1, 2, 3.
Yeah, I think it's going.
Hello, 1, 2, 3.
Yep. It's going.
There we go.
Okay.
All right.
All right. Is it a split screen? That's what's going on here?
Yep. No,
I see.
go.
All right. Now, question is, I do want the other thing to go away. So how do I make that? How do I make that go away? Any idea?
Make that go away.
All right. On the other
Oh, you
thing.
mean-
Oh, sorry.
Oh, over
This thing here. Yeah. Yep. That's good enough.
There.
Yeah. That's
All
what I
right.
think. Alrighty. Okay. First of all, thank you everyone for showing up. These things are always a hit or miss, but to me, I've been doing this job talking for almost 20 years. It's really back in the day when we started this, it was interesting. So it came in waves, right? So initially it was when we started the Philly jug, which is, by the way, one of the biggest jugs in the world. We had like literally 12 people sitting around in a room, like there wasn't even chairs, right? So we sat down on the floor and basically talked about whatever it is that we're going to talk about at that point in time. I think that was back in like Java 1.2 days. So Philly Jug today is 1,200 people and growing. On average, we have about 100 people show up for our talks. But it's always, this is a testament to sort of the power of our platform, right? The people that show up and interested in doing these talks, and you folks are interested in coming and listening to what it is that we have to say. So, as you know, this is the title of the talk. Hopefully you read the abstract. Basically, I'm going to talk about essentially a mashup of a couple of different things, namely Jakarta NoSQL on one side and Azure Cosmos DB on the other. I think Mike did a good enough introduction of me. I don't need to add any more time introducing myself. So let's just move forward. Okay, so first of all, let's start with what is Jakarta NoSQL. Jakarta NoSQL is actually a fairly ambitious thing, right? So it's I have to tell you, like 4 or 5 years ago, if somebody had told me this is what they were venturing to do, I would say they're kind of crazy, right? But I think it is possible, like what the charter of Jakarta NoSQL is supposed to be. And that is basically to create a single API, single specification to talk to all kinds of NoSQL databases. So I think this is something we take for granted, basically, more or less for relational databases. And that makes a lot of sense because all of the relational databases fundamentally implement a standard. They implement the SQL standard. So having sort of a uniform interface for that, either it's JDBC or JPA, what have you, that's a natural thing. To do this for NoSQL actually is not so easy, right? But this is sort of the charter and objective of Jakarta NoSQL. And it is to create essentially one single API where you will be able to access a whole class of NoSQL databases. The reason it is able to do that is because it's not really quite one API, right? In fact, there's a couple of different ways that Jakarta NoSQL adds sort of flexibility in itself, right? So it does that in 2 different ways. Number one is that there are multiple layers, right, that correspond to essentially different requirements and different needs. So first and foremost, there is a communication API, and that is very similar to JDBC in nature. So it's a very low-level driver, often specific to a particular database. So that's the one layer of abstraction. Above that, there is a mapping and template API. And this is much more similar to JPA or Jakarta Persistence. So this deals with a sort of a higher level semantic API that allows for CRUD operations plus querying effectively, and also being able to basically map a Java object very easily in declarative form to your underlying database. So that's another layer that is part of Jakarta NoSQL. And above and beyond that, there is another repository API. So if you're familiar with something like, let's say, Spring Data JPA or Delta Spike data module, it's that, right? So it's the idea that, above all of that, all you really need is a generated set of classes against a particular interface, and the interface simply describes the data operations that you would want to undertake, right? Namely, again, CRUD and various flavors of queries, if you will. So that is yet another layer inside of Jakarta NoSQL. The second way Jakarta NoSQL allows itself flexibility is that it's not really even on so horizontally you have the layers, right? But even from a vertical standpoint, It's actually not a single API. It's a set of APIs. So basically what Jakarta NoSQL does is that it offers a set of APIs mapping to a particular NoSQL taxonomy, right? So, and this is something that has emerged over time in the NoSQL space. Initially, back in early 2000, there was no taxonomy, right? Everybody just sort of came up with whatever it is that they wanted to come up with that they thought was a good idea in terms of NoSQL storage. But over time, what's happened is there is a taxonomy or categories of NoSQL databases that has emerged, let's say, in the past 10 years or so. So those are essentially the taxonomies that Jakarta NoSQL follows. Namely, first of all, this key value. So this is very similar to essentially a more or less a distributed hash map. So there's a get and a put, and you're basically getting and putting by a particular key. A key could be something as simple as an integer or a long. It could be much more complex. In fact, in most NoSQL databases, a key is complex. The key itself actually contains some form of metadata as well. So that's the first key value type of NoSQL database. The value would typically is binary large objects, more or less, right? So it's whatever it is that the user wants to store in the database. And I am hearing my echo once again.
That was me, sorry.
All right, no worries. So the other type of NoSQL database is what's called a column family database. And this is basically much like key value pair, except for one difference. The value that you put into the database actually is not necessarily just an arbitrary binary object. Instead, whatever you put in as values, that is recognized as having column values, right? So think of it as sort of a record. So once you put in a value, that value looks like a record, right? So it has particular attributes, columns, if you will. So that is what a column family database is. One level above that is a document database. So in a document database, the value that you're storing, so again, it's essentially under the hood, it works much like a key value pair. So there is still a key and a value. But the value in this case is actually typically a JSON document. So it's a structured document in some way. So it's not just a set of columns. It's actually a wholly structured thing, right? So it has attributes and nested objects and so on. So that is what a document database is. A graph database is probably the newest entry in this taxonomy. And what this is that data in this sort of databases are represented as interconnected nodes, right? So each piece of data, each, if you will, object or each, record, if you will, is a node in that graph. And then each of these nodes are interconnected in some way. It could be one-to-one relationships, many-to-many relationships, one-to-one relationships, what have you. And each of those relationships can actually have metadata as well, right? So, these type of databases are relatively more rare. They're more useful for, things like mapping, for example, a social network. So that makes a lot of sense. It's like this is one person, this is another person. They're interrelated in some way. Perhaps they're following each other, or one is following the other. Et cetera, et cetera. Those kind of things, and those would be sort of metadata in the relationships. The other thing that, aside from mapping the database, there's a few other characteristics of Jakarta NoSQL that's interesting. So similar to JPA, the Jakarta NoSQL also supports bean validation. So what you can do is not only are you mapping the object to the database, you can also say, hey, this particular object stored in the database must follow these rules, right? So you must validate that this is a valid object before you store it, and perhaps even at retrieval time, you can apply these bean validation rules to them. And we'll take a look at an example of that when we take a look at the code. And it also allows for externalized configuration, right now using microprofile configuration. Again, we'll take a look at that. It's more or less, honestly, sort of a mechanical detail. It's just a way of configuring Jakarta NoSQL, more or less. So there is a lot more coming in Jakarta NoSQL. It is an evolving specification. Believe it or not, it is not yet released. It's a pre-release specification. It is approaching stable state very, very quickly. In fact, I'm going to show you probably what's going to be the last beta release, and before there's a final release of Jakarta NoSQL. So it is getting there. And the other thing that is on the horizon for Jakarta NoSQL is record support. So currently, Jakarta NoSQL does not support records. It simply supports POJOs. But record support is something that the spec group is working on. So that's an interesting, I think, an interesting enhancement. The other thing that is happening is one layer of Jakarta NoSQL, namely the repository API, is actually being split off into another specification called Jakarta Data. In fact, that specification is geared not just towards NoSQL databases, but relational databases as well. Okay, so that's a bit about Jakarta NoSQL. Let me tell you a little bit about what is the actual implementation. So Jakarta NoSQL is a standard, and the JNoSQL is basically its implementation. There's only one implementation of Jakarta NoSQL right at this moment, but it's a very good implementation. It's been around, although it's not final, spec is not final release yet. JNoSQL actually just started as a open source project, so it's a bit more mature than the standard itself. And these are all of the databases that it supports, right? So this is actually, I would say, very good coverage, right? I would say probably of all of the types of things that I've seen in this type, right? Whether it's a sort of Spring Data NoSQL support or Hibernate OGM or what have you, this is by far has the largest amount of databases that it supports for what it's worth, right? So if you're looking into diversity of things that an API like this would support, Jakarta NoSQL implementation on JNoSQL is certainly a very good choice for that. Okay, so before we go too far into the details of our talk today, one of the things that I feel is important to talk about is NoSQL itself, right? So this is a less of a question that I encounter these days, but certainly in at least three or four years ago, this was an interesting question to ask. It's like, when is it that I would even want to use NoSQL? And the answers to that lies in the data, right? So in my day job, I'm a program manager. This is basically what I do is I look at data and try to decipher what exactly is going on in a particular space. So for me, this is very, very interesting. So what I've done here, there's a couple of different ways of taking a look at the pertinent data here to understand what is going on in this space. So this is really nothing much more than Google Trends data. And what I've done here is I've plugged in essentially the major NoSQL databases, if you will, right? So the major ones, namely these would become MongoDB, Redis, Cassandra, HBase, Neo4j, sort of thrown in as a random sample, as a control sample, if you will. And in fact, HBase, you can also argue is sort of a control point as well. But what you see here is an interesting pattern, right? So what this is, as I said, prior to about 2010, there was no such thing as NoSQL, right? So this is basically when all of this sort of came about in the 2005 timeframe or so. So you can see there's exponential growth for a while, right? In fact, growth, I would say, all the way up to around 2017, 2018, perhaps even 2019, something like that, right? So definitely very good growth. So there are a lot of people with a lot of interest in this technology. And then what has happened is sort of in the last 5 or 6 years or so, the interest has sort of leveled off, right? So it's not as much interest anymore. And you can see the little, that's your business cycle dip right there. But it's now sort of in a plateau point. So if you map this to something called something like the Gartner hype cycle, this is where when this technology was under hype, right? So like around 2017, 2018, and now it's sort of found its place. It's in a plateau of stability. So that's an important, first of all, an important observation. The other observation you'll have here is that there's definitely winners and losers in the NoSQL space. So the clear winner is MongoDB, right? But by a very big margin, right? So if you can say NoSQL is almost synonymous to MongoDB, more or less. And the rest of the players, the second most significant player you would say is Cassandra, and there's dozens of these, right? So all of those other ones that I mentioned, if I graph all those out, they would probably be somewhere here, right? So they've never really took off very much, right? So you can see for a long period of time, these have basically experienced more or less linear growth. Now, Redis is an interesting case. So Redis is not a new technology, right? So Redis has been around for a long time. It's mostly a key value type, basically a distributed hash map, more or less. It has actually enjoyed some popularity riding the NoSQL bandwagon, but also not a whole lot, right? So as you can see, Redis has sort of leveled off a long time even before MongoDB, right? So basically the takeaway from this graphic is this is no longer a hype technology anymore. It sort of entered its mainstream and found its place in the industry more or less. So to better understand what is going on in context, what we need to look at is how are these NoSQL databases doing in relation to the stalwarts, right? The existing players, namely the relational databases. So there is a very interesting website out there that just does exactly that. It's called dbengines.com, right? So this is sort of an index looking at the popularity of these various databases, and it maps both relational databases and NoSQL databases. And now you can really see what's going on, right? So because what's happening is basically the top level databases far and away really do remain those relational databases, right? So you can see the top ones are Oracle, MySQL, SQL Server, Postgres. Those are really the main players. Then, of course, there's MongoDB, right? So there's MongoDB, but it's not that high up, right? It's below even PostgreSQL, and then Redis is far below, right? So all of the rest of the NoSQL databases, they actually don't even fall in this, right? It wasn't even mapped. I mean, we basically stopped with somewhere here. So all of those rest of them wouldn't even fall in this graphic. It would be somewhere here, right? So definitely what this means is that contrary to the hype that we saw in like 2010, 2005 timeframe, NoSQL databases really have not taken over, right? So basically what has happened is, it has found a place, in the industry space, but not as a replacement to relational databases. By and large, when you are developing applications, probably relational databases is probably the way everybody is going, clearly, as you can see from the data. But where NoSQL fits is an interesting sort of niche use case, if you will. So if you were to ask me, when you would look at something like a NoSQL database is really two different use cases. Number one is when you have very large amounts of data. And when I say large amounts of data, I actually don't even mean terabytes. Because believe it or not, most relational databases will actually handle terabytes of data just fine. But when you are approaching sort of petabyte range, right, petabytes of data, that will no longer be handled by relational databases because you'll run into physical limitations of disk. You just won't have a big enough disk to handle that kind of data, and you'll also run into memory. So in that case, you will need a distributed database, and essentially that's the real limitation of relational databases, is that they cannot be distributed, right? They really have to be sort of atomic, one physical space, more or less. You could have probably a cluster of 2 or 3 machines, and that's about it. But if you're going to handle petabytes of data, that's not going to happen, right? So you will need dozens of machines to do that. The other use case is geographic distribution. So if you really want data to be available across a large geography, NoSQL databases will not, relational databases will not do the job. You will need to take a look at NoSQL databases. So frankly speaking, NoSQL is sort of a good solution for if you're doing like a lot of volume global scale data. If you have a lot of data that's sort of throwaway data, like say, for example, sensor data is a good example, or some internet sentiment analysis, or something of that nature, right? So it's a lot of data that's that isn't necessarily you don't want to hold on to that much. It's not reliability doesn't matter that much. That's a good use case for something like NoSQL. Okay, so let me stop there, and I tend to not have questions on at the very end. I rather prefer to have something more interactive, especially there's not that many people here, so that's a good space to do that. So let me stop there and Any questions on what I just said? So I went over sort of a basic overview of Jakarta NoSQL. I give you a bit of a flavor for what's going on in the NoSQL space as well.
What do you think is going to happen in the next 10 years or so with NoSQL databases? And please repeat the question so that people.
I see. So in other words, peering into the future, what do we think is going to be the future in the next 10 years for NoSQL databases? Honestly, we have seen these type of cycles many times, right? So once something sort of has gone through the hype cycle and has found its sort of own space, it probably will remain in that space. I don't see it growing exponentially. I think 10-15 years is enough time for us to figure out what's what. So I do think that relational databases will remain sort of the primary data storage mechanism for a vast majority of applications, just because they do their job relatively well. I do think there's in the NoSQL space, we will see more consolidation, right? So now if you look at the NoSQL space, I would say there's in the orders of hundreds of those. Obviously, given that it's its hype has sort of plateaued, and what the use case is, most likely in the next 10 years we'll maybe be looking at a dozen or a couple of dozen NoSQL databases, and the winners and losers will be much more clear. So I don't think we would have that large icon diagram of 40 different databases. We would maybe see 10 or 5 or something like that. So I think that's the real future of sort of the NoSQL space. But there's definitely a place for it, right? So a testament to that is we have a service for it on Azure. So we bothered investing in creating Azure Cosmos DB. So I'll talk about that in a moment next, right? So what is Azure Cosmos DB? So Azure Cosmos DB, long and short of it, is simply a managed database. Okay, so we do have managed relational databases too, by the way. So we have managed Postgres, we have managed SQL Server, we have managed MySQL, so on. So it's the same type of concept. Basically, you want a database. Okay, we'll create a database for you, but you don't have to worry about installing the operating system, installing the database, doing the upgrades yourself, and so on. So all of that stuff is basically managed for you. Sort of more or less a point-and-click interface. Hey, give me a database, and lo and behold, it's created for you. That's the idea behind these managed services. Cosmos DB, though, does have a few characteristics worth noting. So first and foremost, it is globally distributed. It is multi-model. I'll talk about what multi-model means in a moment, but it is globally distributed in a true sense, right? So basically, if you create a single instance of Cosmos DB, you can say that single instance data will be, if you wanted to, available on every single Azure data center out there. And we have dozens of them across the globe, right? So truly, if you want truly distributed data, guess what? If you do this with MongoDB, you're going to have to figure all that stuff out, right? But with Cosmos DB, it's just there for you, right? So if that is a use case that you're after, Azure Cosmos DB is a very good answer for that. Now, the next part is that it is multi-model, right? What does that mean exactly? What that means is that similar to sort of the realization of Jakarta NoSQL is that there's multiple different types of databases that we need to support. Cosmos DB essentially has come to that same realization. Okay, so there's multiple different essentially NoSQL families that the single database supports. Okay, so at the core of it, it is actually something that looks a lot like SQL. And the SQL language is supported very much by something that looks a lot like a column family. Okay, so more or less a name value database, but each value is sort of columnar. It's a record. And by the way, one interesting thing that we actually have just GA'd not too long ago is that you can actually use PostgreSQL as your API, right? And have Cosmos DB be the actual implementation, right? So this is sort of flying in the face of the idea that relational databases cannot scale, because we're trying to do precisely that, right? You'll be talking as though you're talking to a Postgres database, but actually it's under the hood, it's Azure Cosmos DB. The other API that Azure Cosmos DB supports is MongoDB. Okay, so it exposes a document database style of access. It also supports Cassandra, right, as an API, so it'll behave as though it is a Cassandra database. So again, that's a column family. We do support graph databases as well. That is through another interface called Gremlin. Okay, so you can use Gremlin to store graph data instead of Cosmos DB. And finally, we have just plain old key value database as well. So it's something called Azure Table Storage. So literally just key and value, and then whatever you put in there as value, that's up to you. And reading and writing that is all up to you. So the other thing that we do here is that we add, aside from supporting these APIs and global distribution, the other thing we try to do is focus on enterprise use cases, right? So what do enterprises need? They want a database that's going to be available, 99.999 crazy amount available. We focus on performance. We do some pretty interesting benchmarks. Even in a globally distributed database, we guarantee that you will access your data no matter where you are in the world in a nanosecond latency time frame, right? So that's a very tough thing to accomplish, but that is something that Azure Cosmos DB will give you. And of course, scalability, you can scale up or scale down. If you just want one instance of data in East US, that's perfectly fine with us, right? Or you can scale up to whatever maximum scale that Azure will allow you. And we also focus on security, right? So on the cloud, security is a major concern. And of course, it's a major concern for Cosmos DB as well. Okay, so moving forward, I'm going to now dive into the code, right? Without done enough of a lecture, I think it's now time to show you some stuff. And hopefully I have my glasses handy. Yes, I do. So before I do that, any questions? Yes, sir.
So, the support for those different NoSQL database types.
Mhm.
So we said I can have an account on Cosmos DB, but I can do
Any one of these APIs? Yeah.
so how does that work?
It works basically like, so you do need to make an choice, by the way. So you can't switch midstream, right? So when you're saying I want to use Cosmos DB, and you're going to spin up a Cosmos DB instance, you have to make a decision what type of Cosmos DB do you want. Okay. Yeah. So you say I want Cosmos DB for MongoDB, right? So and it's going to give you essentially an instance that looks and behaves like MongoDB in its API. Mhm.
So if you had a Mongo shell.
Yep.
Mongo shell, do all your MongoDB commands.
Absolutely, you can connect the semantics of connecting the connection string looks exactly like any other MongoDB API. The binary protocol is exactly like what MongoDB provides. So anything that supports MongoDB, you can just point it to Cosmos DB, and as though it's like, okay, you're just talking to MongoDB with sort of the managed characteristics of runtime characteristics of Cosmos DB. Same thing with any one of these. Yeah. It's a very neat concept, and in fact, we have a lot of users. Not, of course, again, following the general industry trend, not as much as we have, our DBMS customers, but we do have a decent number of customers using Cosmos DB as well. Pretty big ones.
I like that you have database type.
You're gonna have to repeat.
Oh, my apologies. So the question there was, how is it possible that Cosmos DB can speak all these languages, if you will? So the way we solve this is basically you pick your identity before you get going, basically. Yeah, and it behaves like that particular database thereafter. Okay. Any other questions? Yes, sir. Mm-hmm. Yeah. So this is a bit of a truth in advertising here. So, oh yeah, the question. Okay. So the question is, if you choose PostgreSQL as your interface for Cosmos DB, is it going to behave just like Cosmos DB? So the answer is yes or no, yes and no. Okay, so it will behave like Cosmos DB as far as its SQL semantics. So if you're just spinning up like let's say a SQL client and or a client or an application that was written using PostgreSQL, using the PostgreSQL features and PostgreSQL semantics, right? It'll work as the same, right? All of those SQL statements will work exactly the same. All of the PostgreSQL features will work exactly the same, with one exception. Okay, and it's a big one, namely that you will not have transactions. Okay, so it'll be like you're working in auto commit mode. So that's the secret sauce. That's how you can you're able to geo-replicate across boundaries and allow NoSQL characteristics, is by relaxing that one constraint, namely that you don't get transactions. So other than transactions, yeah, everything else will work.
Services that Azure provides, which is really like Postgres, those are just Postgres.
Those just Postgres. Yeah. Mhm.
This one.
Yeah. So the question is, usually, is there a normal Postgres? And absolutely there is. So there's a normal managed Postgres service, and that is truly Postgres. And it, NoDB basically, is the engine for that. It's not Cosmos DB, but yeah, this is a PostgreSQL facade over Cosmos DB. Yeah. Okay. Yeah.
Years ago, and we were and in that moment, we worked like with the MongoDB version 3.2. What about now?
I don't know. So the question is, when you worked on Cosmos DB a few years ago, it's supported a slightly older version of MongoDB. I don't know the answer to that, to be honest. But the document, if you go onto the documentation, it should tell you specifically what version it is. I do suspect it's relatively recent, but I don't take my word for it. I don't know the answer to that right away. It's worth checking. Or size is it? Size is another question, right?
We can switch it up.
All right. Okay, any other questions? No? All right. Okay, so about the code. So the code is available on GitHub, by the way, and it is intentionally structured to be self-service. Okay, so this is not just here's some code and you figure it all out. That's not the case. So I'll show you the GitHub repository in a moment. The intent of the GitHub repository is that whatever it is that I'm demoing today, you should be able to demo the same thing yourself just by going through this GitHub repo. Okay, so let's go ahead and open up the GitHub repo, and I can show you what's what. Oh man, I do really dislike Zoom. I have to be honest. I can't even minimize my window. There we go.
You're a Microsoft Teams man, eh?
Yeah, I have to say that is absolutely true. I like it a bit better.
I hear good things about
Yeah, yeah, that's also not bad, or not as clunky as Zoom, let's say. Okay, so all right, so let's go in here and where are we? Okay, so here's the repo. It's also linked in the slide, by the way, and I'll share the slides. By the way, are also public. They're on my speaker deck account, so you can take a look at that as well. So this is how the repo looks like. Okay, so these are all the setup instructions. So you can go ahead and set up your environment by yourself. I've given you instructions on how to do that. All we're really doing here is spinning up a Azure Cosmos DB instance. So here's the instructions on how to do that. You will need a Azure account, okay? But Cosmos DB is free, right? It has a free tier. You don't have to pay anything for it, and you can create a Azure account also for free. So honestly, it's no big deal, right? Pretty much anybody can do this. So there's the instructions on how to get set up with all of that. And here's the instructions on how to actually run the application, which I will do in a moment. Bit of advertising. Honestly, this is just one of many repos that I maintain. So there's some things on my to-do list. It is an open source it's in GitHub repo. I'd certainly welcome a contribution, right? So the two things that I've been intending to do with this and just haven't had time to do is right now, the demo that I will show you will be using the MongoDB interface for Cosmos DB. I'd rather like to have also examples using Cassandra and Gremlin. So in theory, the work should be very minimal. You'd be using the same sort of API, only a different API taxonomy. But basically, the fundamentals of it should be very, very similar. So all of the code itself is there. As you can see, it's just a Maven project. So all of the code I will show you in Eclipse rather than here, but it's also available on GitHub. Okay, so let's take a look. The other thing I've done is, in the interest of time, I went ahead and created a Cosmos DB instance. Sometimes it takes 10 or 15 minutes to do that, and I don't want to waste 10, 15 minutes spinning up a database instance in the middle of a talk. So I've gone ahead and done that. Okay, so here's that instance. As you can see, if I click on here, it'll say Azure Cosmos DB for MongoDB account, so on. And we'll look at the data explorer in a moment. We won't do that as of yet, but basically what you can see is that there's some activity going on in this database. So I'm basically I was playing around with this, getting ready for my demo. Okay, but the main thing to note is that I do have a database up and running. It's running on Azure. Okay, now let's open up my my Eclipse, and you don't have to use Eclipse. You can use whatever IDE you want, or you can not use an IDE if that's what you wish. Ultimately, this is just a Maven project. Okay, so I'm just going to go ahead and basically do a demo for you, and then explain what exactly is going on in the demo. So let me just do a Maven clean here. Run as, come on. Oh dear. Okay, there we go. Good. I was gonna say, is Eclipse hanging on me or not? Okay, so yeah, actually, this would work just fine, like command line too. There's no particular reason to have to use an ID for this either. All right, so what I have here, the demo that I'm going to show you is actually just a unit test. Okay, it's as simple as that. I tried to keep it just as simple as I could. So I'll show you exactly what this unit test is doing. It is basically interacting with Cosmos DB here. So first thing I did is I saved some data. I saved 3 orders. You can see that. I did a find by ID. Okay, so I inserted 3 records and retrieved 1 by ID. Then I did a little bit of a slightly fancier queries. Okay, so these are the queries that I did. So these are the find by ID that I did, and these are the sort of more fancy queries. So I'm finding orders with cost above a certain amount. I'm finding orders that has a pinball in it. You know, finding orders with a machine, so on and so forth. I'm doing a quick update of an order. And then finally, I'm, of course, testing a delete. And then I also wanted to test out the bean validation integration, which I'll show you in a moment. Okay, so I'm testing the validity of the order. And as you can see, you know, at the NoSQL and Jakarta NoSQL is telling me, hey, this order that you're trying to inject is invalid. And these are the reasons why it's invalid, right? So you can do all of these things. Basically, this is a demo. It's basically a CRUD application. So let's take a deeper dive at, and you know what? I'm just going to show you this in the browser. Are you folks how conversant? Okay, thank you. Oh, thank goodness, this thing is finally got out of my way. All right. So all right. So here's the code. Let me increase the font a bit, if I may. All right, I think that's good. All right, so first and foremost, you know, I'll show you the POM. And where is the POM specifically? All right, there it is. Okay, so it's a very simple project. Really, I just have NoSQL mapping, right? The mapping API as a dependency, and I'm using of type document. Okay, and I'm using a MongoDB driver So this is the JDBC layer, the communication layer in play. And I'm just actually spinning up everything in a small CDI container weld, right? So it's not a web application, it's just a unit test. I'm using Hibernate validator as my bean validation implementation, and I'm using small config and JUnit, and that's about it, right? There's not really a whole lot to this in that sense. So now let's take a look at the test that I ran for you. And this is the test, okay? So first thing I do here is that I create an SE container. So this is a dependency injection container that I'm creating, okay? And I'm creating a type of template, okay? So if you can see the type of this interface is document template. So this is very similar to JPA, only of the document database flavor. And then first thing I'm doing is just clearing, before I start my unit test, I'm just deleting my set of records or tables, if you will. So I'm deleting all of the orders. Then here's my persist operation. Okay, so I'm creating a new customer, creating a new order for that customer, setting up a bunch of data like the customer name, the description, the customer's address, a few order lines that I'm adding here, and then there's the insert statement. Okay, this is going to cause me to create a new document in MongoDB. Another order being inserted here, and yet another order being inserted here, as you can see. And finally, my assertion is simply that I have 3 records in my order class. Okay, all of class order, of document type order. Then I'm simply doing a find by ID. That looks very much like JPA, right? It's just find, whatever the class of the order is and the order ID, and that's about it. And here's my queries, by the way. So the reason I'm able to do these kind of queries is because this is a document database. I could also do similar things with, if I was talking to a column family database like Cassandra, okay? Query facilities are not going to be there if you are using just a key value database, because those do not support queries. They're also not going to be there for graph databases, right? You cannot issue a query against a graph database. What you do there is you traverse the graph to find out whatever it is that you want to find out. But semantically, this looks very much, whatever the underlying semantics of the NoSQL database may be, semantically at the Jakarta NoSQL side, it looks very much intentionally like SQL. Right? So you can see the syntactic similarity there. MongoDB, by the way, does not support anything that looks like SQL, right? So that's a very different query language. So this is another very good benefit of using Jakarta NoSQL, is that you get to use basically a construct that you're more or less everybody is familiar with. So you can see that I'm using a where clause, right? A like clause, like again, just like in SQL. And I can also do nested conditions, if you will. So I'm searching for an order, and inside of order, there's order lines. And then I'm looking within those order lines, I'm looking inside the description field to see that if it equals machine, right? So you can do these kind of things as well. So this is implicit joins, if you want to think of it that way. So here's an update. Update is simply do a find, do whatever it is that you need to do. In this case, I'm adding 2 different orders and simply issue an update statement. And then in the finder, I'll see that my total cost has changed because I've added some order lines. This is remove. Remove is very simple. It's just give it the or type of document and its ID, and that's about it. And then the testing the validity of the order. This is what I'm doing. Right? So I'm creating an empty order, right, and then trying to insert it, and then validating that it will fail. Okay, so Jakarta NoSQL is doing the data validation for us here as well. So now let's take a look at the things that are actually being mapped. Actually, before I do that, let me show you the data, right? So fundamentally, when you're doing all these things, you can actually look at how the data looks like, and you don't actually need external tooling because Azure comes with a basic mechanism to look at what's inside of your databases. And that is specific to each database type. So in this case, I have this database here. And you can see I have a couple of different order documents, right? I can pull one of those up. And I think I have a tiny bit of latency here. But okay, let's take a look at this guy here. So this is how this is under the hood stored as JSON. Okay, this is a JSON document. So you can see the ID of the order, the zip. Here's the order lines. Okay, you can see they're stored as JSON arrays. Okay, there's city, street, etc. And you can see even the customer is a nested JSON object. So this is how the data looks like. So looking at the code itself, this is how the order object looks like. Okay, so this is the thing that I'm saving. And what you'll notice is this looks a lot like JPA, right? So there's a column annotation, there's an entity annotation, there's an ID annotation. There's all very, very familiar. In fact, I'm using the mean validation annotations as is in here as well. So basically, just like you do in JPA, you mark something as entity. Okay, you can also mark something as embeddable. We'll see that in a moment. You mark your ID with the ID annotation, columns with the @column annotation, and there you have those bean validation annotations. So I'm saying that string must be not blank. Okay, I'm saying that the cost must be positive or 0, etc. Right? So you can specify many different bean validation annotations like this. But as you can see, there's fields, and then there's more complex fields as well. So there's a list of order lines, there's a customer, and then there's an address. If you look at and other than that, this is just primarily just getters and setters. There's really nothing much more there. A little bit of business logic in the add order lines method, and a little bit of a fancy toString method, and that's really what you were saying, in your unit test there. So if you look at address, okay, it is actually marked as an embeddable. Okay, so that it's just like JPA. So and similar type of idea. Other than that, very similar with the address class as well. Right, and yet again that is an embeddable. So you can see just how easy this is, right? So somebody who is familiar with JPA, or even if you're not familiar with JPA, it's a relatively intuitive interface, right? So basically you have your POJOs, you want to save them to the database, you mark it with entity, you specify what mappings you need, and the API is just like the one you saw. It's just inserts, updates, deletes, do a query, and the like, right? So this is far and away taking away a lot of the complexity involved in learning each NoSQL database and understanding its particular semantics and whatnot, right? So all of that is basically taken away as sort of infrastructure concerns, and really you're dealing with a single API to deal with these, to do these interactions with the database. So let me stop there. Is there anything of the code that you'd like me to show you in more detail? Yes, sir.
And it's asking for an example, a scenario where it's essential to have a multi-model managed database.
It's essential to, okay, all right. Is there a use case what is the use case for a multi-model database? So I think implicit in that question is really, I think what you're asking is something that Azure Cosmos DB does not do. Okay, so namely, you cannot decide to store data and then change your mind later that, oh, I stored the data using the MongoDB interface. Now let me turn around and try to access that data using Cassandra. That doesn't work. In fact, it doesn't exist. There's no such database that will allow you to do that. And Cosmos DB doesn't purport to do that either, right? So you do have to make a decision of what type of database you are going to be using when you create the Cosmos DB instance, and that's it, right? So if you need to use another type of database, you can't just take that data and try to access it through another interface. The reason for that is that the data storage mechanism for each of these is very specific, right? So these are not mutually compatible APIs, right? Each of these databases have different semantics. So frankly, I don't know what the use case is. Like basically somebody who can't make up their mind, maybe, right? Or somebody whose business needs are evolving, right? So perhaps you're starting with a NoSQL key value store, and then you decide, oh, I really need a document database. That's possible. There's no database that will allow you to just transparently switch like that, you will need to do a data migration. So typical data migration steps would be you have to unload the data in its format and store it in some other canonical format, and then reload the data in some other format.
While you're continuing, I'll check to make sure that you answered the question on YouTube.
Okay, yeah. So why do we have another way of interpreting that question is why a multi-model database? Here's the reason why. So think of Cosmos DB as the infrastructure more than a specific type of database, right? So whatever type of database you may choose, whether it's document database or key value database, fundamentally the runtime characteristics are going to be the same. Okay, so it's going to be the same geographic distribution model, same infrastructure to allow you to do geo-replication, same infrastructure that's doing security under the hood. It's just that the particular data that's being stored is a bit different, and the way you're accessing the data is different. But for the foundational infrastructure is exactly the same, right? It's Cosmos DB one. Either way, it's just Cosmos DB as a convenience is speaking different languages and storing data in slightly different ways. Okay. Any other questions?
Annotation. When we want this today, and we have annotation and other validation annotation. It's they work in different places. For example, when we store object, we apply limitation in annotation column and so on. It doesn't work annotation like num and so on. In your case, our limiteds working before storing. We use Hibernate annotation. This annotation is like .NAM.
Sure.
Can we apply this logic in column from GPA? For example, we would like to create DB, like structural DB, on start application. Provide some information about size and so on. So it's also like in GPA, or we have some different logic for column annotation.
Let me try to understand the question. I think what you are asking me is, can you change the bean validation rules applied on a POJO at runtime? And that's what you're really asking.
Yes.
Okay. Is that fair? Is that the question?
Yeah.
Okay.
Mostly in GPA, validation annotation doesn't work when we persist objects. Just working on GPA annotation like column. In your case, when we store object in using non-SQL API, we work with validation annotation. What's the reason of using annotation column in your case?
Barry, do you follow the question? I'm a bit lost.
Trying to make sure that you repeat the question.
Right, but
Would you like to use the mic there? And
yeah.
Okay. Could you please open some object?
Okay, yeah. Please, let's do that.
Well, I don't mean to hijack the presentation.
No, it's really fine. No, it's fine. Maybe you'll help me understand what's going on.
Column, we have annotation not blank.
Get closer to the microphone.
Sure.
We have two annotation column and not blank. Not blank. It's from validation API.
Sure. Okay.
And in JPA, when we store persist object, this annotation doesn't work. This
Really?
annotation
Okay.
not applied process storing object to DB.
Okay.
In your case, in non-SQL, this annotation works when we persist object, like persist object to non-SQL. What's the reason of annotation column? Just show it that it's this column, or we can use another options.
Yes, absolutely. Most obvious one is that you see, when you have a POJO, you don't want necessarily every single thing in that POJO to be stored in the database. So the column annotation in this case is basically telling the provider, hey, this is a thing that you should persist. Yeah.
There is some options in column.
Yes, there's column, there's obviously name, you can override the, so in this case, the default name of the, in the database would be description. But let's say you want to name it something else like desk, right? So you can specify a name override in column, and I believe there's a few other attributes there as well. But the primary reason you had the column annotation is because you're literally telling the engine, hey, please persist this, as opposed to ignore it. Yeah.
We okay?
Yeah.
Okay,
Yeah.
all right. And I have a question from you.
Yeah.
Okay. I think, it's a statement with a question mark at the end of it.
Mhm.
And the statement is the definition of entities will remain the same irrespective of whichever flavor, MongoDB, etc. we choose.
Yes.
Question mark?
Yes. So that is not 100%. Yes, not 100%. So the question is, if you mark something as entity, is it the same thing? Does it mean the same thing? Whatever type of database you're using with the NoSQL case, right? So let's say you started with this data model and you decided later on, oh, I'm not going to be using MongoDB. I want to switch my communication layer and infrastructure layer to use Cassandra instead. Is an entity still an entity? So the answer to that is maybe. Okay, so there's certain annotations that remain the same no matter what type of underlying data store you're using. So entity, ID, those are essentially the same. Column, those are essentially the same. But there's certain type of annotations that will not work. Okay, so for example, if I was trying to make something embeddable, which there is an example of here, right? So I have an embeddable customer and an embeddable address. Well, that's only going to work if I'm using a document database or a column family database. It's not going to work if I'm going to use a key value database. That annotation will simply be ignored. It won't even be saved. So you do have to be careful. It's one API, definitely the mapping API is different. So there's document template versus key value template, but the annotations, while they're reused across different APIs, they don't necessarily translate as is. Most of them do, not all of them.
Just wanted to
Okay.
follow up on that. I think in the implementation of part of NoSQL, which is JNoSQL, I think there are specific annotations specific to database.
Right.
Like Cassandra, their query language, there's an annotation for that. Same thing with the MongoDB, there's an annotation of that. So in the implementation, that's where you're going to see a lot of these, various differences.
Yeah, so that will be when it'll be interesting if somebody wants to contribute, let's say a Cassandra port of the same application. We'll see that not everything quite works exactly the same. There's some differences. Yeah. Okay. If there's nothing else, I'll switch back to the presentation. If not, if there's any other questions on any of this. Yeah. It's fine. Has there been any legal pushback on in doing any of this? The answer is no, right? Because we're dealing essentially what this is an abstraction over other databases, right? So nobody's really violating the IP of MongoDB. MongoDB is what it is. It's being used under the hood over this abstraction. So the answer is no, not really. Yeah. Okay, sure. Okay, any other questions?
There's a remark here. And it says our cloud infrastructure is AWS. Gulf Cloud, can we use Cosmos DB in AWS?
No.
Yeah.
Okay, can you use Cosmos DB in AWS or any other cloud? The answer is no, it's specific to Azure. Yeah. Okay, all right, any other questions? All right, fair enough. So let me move back into the presentation. Actually, I'm almost quite done. All right. So actually, I just wanted to share some resources with you and just wrap things up. So again, Jakarta NoSQL is a emerging standard for accessing non-relational databases, just like you have JPA. It's part of the Jakarta EE umbrella. It's one of the newer specifications in the Jakarta EE umbrella. I've also showed you a bit of Cosmos DB. Really, Cosmos DB in this case is a sort of a implementation concern almost. But Cosmos DB on its own right is worth exploring, right? There's a lot of other things that are in Cosmos DB that are not necessarily relevant to this particular talk. But essentially, it is a managed database on managed NoSQL multimodal database on Azure. You can use these technologies together in any Java application, in fact, in a Jakarta EE application, if you so wish. And hopefully the demo is going to be a decent starting point for you to help you. So in terms of resources, if you want to learn more about Cosmos DB, which if you're going to do a Cosmos DB, if you're going to use Cosmos DB, Jakarta NoSQL, you should. So the best ways to learn that is really the Cosmos DB website and the Cosmos DB docs. I think they're quite good. They're quite comprehensive. Similarly, if you want to learn more about Jakarta NoSQL, the best place to do that is actually read the spec. Okay, the spec is available. It's under jnosql.org/spec. And if you want to learn more about JNoSQL itself, like for example, what databases does it support, that kind of thing, the place to do that is jnosql.org. So let me finish by showing you how to get to this presentation. It's simply speaker deck. Okay, and my name, that's my account. And in here actually is all of my talks, and this slide deck is available here. And if you want a PowerPoint copy of it, just email me and I'll send you a PowerPoint copy. It's perfectly fine, should you need that. That's about it. Thank you for your patience. I think I'm okay time-wise. I think I was supposed to finish at 6:30-ish, wasn't I? So I'm a little bit over, but yeah, I think not too bad, I hope.
For the benefit of any students who are watching the YouTube and who are here, and any of my colleagues who see this presentation, can you say a little bit about the importance of databases in education and in your recruiting efforts at Microsoft and at any other company? How important is it for students coming out of college to know all about databases?
So frankly, the answer will vary. Yeah, okay. Please explain the importance of learning databases as a student. Okay, and I assume this undergraduate or graduate or what have you, right? So frankly speaking, the answer depends a bit on where you are applying. In all fairness, at Microsoft, and I'll tell you, a lot of the Microsoft people, people like me, are an exception. Right, so Microsoft tends to not hire people from the industry, unfortunately for us, right? They don't do that. They only do that in certain exceptional cases. Majority of Microsoft employees are lifetime employees, right? So basically they got out of school, probably with an undergraduate or graduate degree, got into Microsoft, and basically they've spent their entire career on Microsoft. That's the norm. Okay, so for those type of employees, so we do frankly majority of our hiring happens in on campus, right? That's how our majority of our employees come about. For those type of hires, we actually don't expect something as specific as JavaScript, or do you know Java, or do you know databases or not. In all honesty, what we are looking for there is actually general aptitude, right? So if you happen to be applying to Google or Microsoft or that type of company, you just need to be pay attention to your courses, honestly speaking. And in fact, you're probably your 200, 300 level courses more than your 400 level courses, because you're not going to be really tested on that. What we're going to ask you to do is test your critical thinking abilities, test your sort of theoretical depth, so big O notation kind of thing, and 200 level algorithm classes, that kind of thing. So in the exceptional, narrowly focused world of Microsoft and Google, probably if you don't know databases, it's okay. All right. But here's the reality: if you don't happen to be getting into Microsoft and Google, and we are terribly selective, I think our acceptance rate is something like 1%. So it's like getting into the Ivy Leagues, or probably even more stringent than that. In the real world, yes, you will need to know. There's no such application that doesn't use a database. And even if you're wanting an entry-level job, you will need to learn databases and quickly. So save yourself some pain and learn it before you hit the job market, is what I would say.
I don't see any other questions on YouTube, so.
And I don't want to, I don't mean for this to turn into like a job fair type thing.
Sure. Either way, I'm going to tell you to go to Microsoft careers.microsoft.com. But
Very, like, it seems very, where it's like, computer science, like something very sort of branch.
sure. Okay.
So, like, how is that perception for you? Like, you are wanting to go to like some career like this, but with a focus in terms.
So is this undergraduate or graduate program?
I'm doing both.
Okay.
I'm doing whatever,
Okay.
hopefully.
Yeah. So it's like anything else. It's a trade-off, right? So it's computer science in general is you're not going to be worried about getting a job, right? So you're going to get a job if you have a computer science degree. It may not be the best job that you want. You will have one because our unemployment rate and for computer science degree is very ridiculously low. It's probably in the single digit, right? So that's not so much a concern. If you want just a job, getting a general computer science degree is your best bet. If you have a specific type of interest, for example, cybersecurity, in your case, the reality is you will be narrowing your options for sure, right? So, somebody looking at your resume versus looking at a computer science degree, they're probably, if you're just hiring a generic software engineer, I hate to tell you this, but they're probably going to hire the computer science person, right, over you, right? But the thing about it is, in some ways, for the right job, you'll get a leg up, right? But you are narrowing your field, right? So there is cybersecurity jobs at Microsoft, many other companies. It is somewhat specialized, right? I don't know that your average M&T bank or Walmart IT probably doesn't have that many jobs in cybersecurity, right? So you are narrowing your scope a bit, right? But yeah, again, as long as you're able to find the right job, you should be okay, right? Because you have an advantage over somebody else. It's all about trade-offs, and ultimately you have to ask yourself, what is it that you're interested in doing? Yeah.
I honestly feel like, no matter which software, like subspecialty and databases come in some way. Even QA developers have databases, designers have good. There's always some tangential information that if you know at least the basics of databases, it's going to help you in the long run. Like you might not be programming it like a web application if you're in design or one of the other fields, but it's going to help you somewhere. You kind of use it. It's good. It's good to know the tooling.
Okay, are we all set? Yes, sir.
Is any of what we discussed today used in ChatGPT? I know ChatGPT.
I have no idea, man. No idea. Yeah.
The question.
Is any of this used in ChatGPT? I really have no idea. I'm pretty sure ChatGPT uses a neural net of some kind, and probably genetic algorithms by the look and feel of what they're doing. Beyond that, I haven't looked into it. Who knows what they're using? Who knows? Maybe that's all it's doing.
Not the core engine.
Right. Maybe it's just a fancy old if then else statement. Yeah, could be.
Anything else on YouTube?
I think we're good.
Well, let's give Reza a round of applause.
All right. What's the teardown process here? I don't want to abruptly mess something up. Oh, okay. All right.
Barry.
When we don't have the. Did you send me your other presentation?
Right there.
There we are.
Oh, it's pretty big. Awesome. All right, Reza, thank you very much. Appreciate, well, first of all, coming out at the last minute. I'd mentioned at the beginning that we had some scheduling. Mark Heckler, who actually came to visit with us in 2019, 2020, was planning to be in New York City 2 weeks ago. And then it was going to be virtual, and then he wants to come out real, in person. So that was part of the scheduling. And then we had somebody scheduled for February, but they're not coming out until maybe June. So we've been battling a lot of these, reworking and stuff like that. So, but we will get it together. But we got some great speakers lined up. I'll show you that in a minute. So what I want to do is talk about Food.io. And this is an initiative that started, I want to say, about 2 years ago, if I'm not mistaken. And Food.j stands for Friends of OpenJDK. And so what I can do is demo some new stuff. Just real quick, you can look more in depth at home. All right, so this is the main page right here. So some of the stuff here, if you look under community, you have Java user groups. And we are, oops, Control F. So we are listed here, and it goes right to our website. And it's not just having the user group listed, but are the groups active? And it had the date from our original date this month. So it does say, yes, the Garden State Java group is active. So
You have to do share screen.
am I not sharing?
Share screen, on Zoom.
Oh, on Zoom. Okay, sorry about that, folks.
There we go, share screen.
Okay, sorry. All right, there we go. We'll get all this together at some point. So, okay. It's being projected here, but I didn't realize we weren't projecting over Zoom and YouTube.
Normally here is the entire world.
Right.
But we just have to respect YouTube.
The real entire world, right?
Yes.
So yeah, so we are here listed on here. And you can see there's a whole bunch of groups, and I'm sure New York isn't here and all the others, right? So that's one thing. There are great resources. How come I can't go there? When I did this earlier, it gave me some other stuff. What's that?
Community Hub and bottom UO. No, and Community Hub.
Community Hub, right?
And UO.
Oh, there, view all. Okay, gotcha. Thank you for catching that. So there's all right. Well, there's a whole bunch of stuff, resources for students like we have here. So for newer people into Java, and you can peruse those. And I can't really seem to find them right now, so I apologize for that. What else? There are you could check out all the different events. There's a calendar that will come up. And you can see upcoming events, not just for other Java groups, but the different conferences that are going to be happening within, whenever they have on the calendar here itself. So it's really cool. There's a bunch of blog posts on how-tos and this and that. So while I'm thinking about it, Reza mentioned before about contributing to open source. I don't know, have you guys in particular done any of that kind of work? Like to contribute to do the full Git, creating a branch and doing pull requests and all that good stuff?
I've done that for like a class, like the software engineering class.
Okay.
But, like not to like an actual project, like just like a project within like a group of my classmates.
Okay. Would it be worthwhile to maybe next month or to do a quick 15-minute demo on how to do a contribution?
Oh, actually, for sure.
Okay.
Like
cool.
If we get enough students to do that, it's actually something that's kind of not really looked at too much.
Okay.
So
Yeah, we could do the full life cycle on that, so.
One way someone told me that, I don't know if it works. If you're going to get started to contribute to open source project is look for like documentation errors and typos.
Yep.
Submit that as a pull request, because at least that gets you practice of doing the pull request, submitting it, getting it approved, merging it. Even if it's not the most exciting change, I don't know if it actually works, but I've heard people, I heard a speaker say that once, but that's a good way to start.
It's a good way to get started, other than contributing code. And, I got into it about, not even but a little over 4 years ago. And so it's a worthwhile thing. It's you feel like you've, made a difference, in an open source project. So, all right, we'll plan for that. Like 15 minutes just to start that thing. But this is a great resource here. And you guys can check that out, even thing with Java Champions, that kind of thing. So, so anyway, give that a whirl. It's fuj.io. We'll go back to our slides. All right, some upcoming events. I know I've had this Java Day up here the last few months. This is still a work in progress, so I kept it here for now. But there is a local conference coming up in the College of New Jersey in Ewing. And the IT Professional Conference is Friday, March 17th. And this is, so it's like $150 to, for your employer to send you for the day. There is a suite of talks. I can actually go back and show you real quick. I'm running into this thing here. There we go. Let's see, it's Princeton. Of course, I'm not on my laptop, so it can't really. m.acm.org/t. Let's see if I got that right. Oh, how about that? All right, so March 17th, I took over as chair of this one-day conference. The last 2 years have been online, so we are back in person at the College of New Jersey. We have a keynote address by Rebecca Mercury on cybersecurity. She's a great speaker. She was involved somehow in the 2000 election. I think a lot of you weren't even born then, so but that was quite the memorable election back then. Yes, that's right. Yes, she was an adjunct. That's right. These are the speakers we have confirmed so far. I got an abstract from somebody the other day. I need to add that person on here. Corey Becker is going to talk about something artificial intelligence related. Let's see. Oh, multimodal deep learning with an application to folk art recommendation. So there's a variety of different talks. There's Rebecca, building modern data stream apps. So these are the kinds of talks that will be presented. This is using a finite state machine in large scale system migration. I'm going to make sure I attend that one. I'm kind of interested by FSMs. So anyway, if you're interested in going, there's a discount for students, by the way. So $40. All right, and you get a free lunch, and there's continental breakfast, and I believe there's coffee, available all day. So I'm trying to make a push for beer at the end, but no, I'm only kidding. But yeah, so if you get a chance to come down and see a different campus, you can appreciate you coming out to support that. And then there's the regular TCF, Trenton Computer Festival, on Saturday, full suite of talks on all different skill levels. And so your entrance here will get you entrance into Saturday as well. So there's a lot of benefits to, for the price of admission. Okay, and if you're interested in presenting, please let me know, because there are maybe a couple of spots open. All right, so upcoming meetings. So because we had to do a lot of scrambling, I had some folks here, but I just thought I'd have the list of folks we are going to schedule for this year. So Matt Rabel, I understand, will be available in October to be here live. Rustam Memandarov in June, I believe. Just started getting into talks with Cameron Purdy. And so he was asking about, when, and, so he hasn't gotten back to me yet, but it sounds like he's interested. Mala Gupta is from JetBrains, developer advocate. I think she'll be in the area, March and September possibly. Reza Rahman will be presenting on the top 10 Java features. He'll most likely be remote, and he also just, his wife gave birth to their first child over the past week. So he'll be busy for a while, so we won't see him till later this year. So, and then Jonathan Schneider to talk about open rewrite. And then I just asked Trisha G if she'd be interested in presenting to us and when she'll be available. So these, this is a kind of the outline of what we're trying to flesh out for this year. So yeah, upcoming meetings from the Friends of JSJUG, the Boston Jug or New England Jug, February 9th, mutation testing, the Chicago Jug, February 15th, Java under the hood of Elasticsearch, which I believe is supported with Jakarta NoSQL, by the way, just FYI. Atlanta, they are having a hotspot versus OpenJ9. Which one to choose to cut cloud bills? That's on the 21st. And let's see, the 22nd, the Philly Jug, image and video processing in Java using OpenCV and Pile CV4J, both of which I've never heard of. So, but this Jim Carroll is the CTO of one of those companies. Yes, we're done. So thank you very much. All right.